Okay, Venn diagram is another representation of a set. Uh, we have already two ways of expression of set, which are set builder form and tabular form. In these two forms, we just write the elements basically in roster form or tabular form. We have to write all the elements using comma within second bracket. And in set builder form, we have to define the elements. These two types of representation of sets already we have discussed. And this is Venn diagram. It is it's not properly representation, but with the help of diagrams, with the help of two types of figures, the mathematician when developed this concept that sets can be represented, can be interpreted uh, using some diagrams. And from the diagrams, he picked up only two types. One is circle, another is rectangle. So a rectangle basically used as the universal set, under which set we consider some sets, some operations, elements, behavioral of their intersection, union, difference, all these things among certain sets to interpret. These sets will be definitely under a biggest set, and that one universal set. So for universal set they use the rectangular shape, and for other sets use the circular form, circles. So with these two types of two-dimensional geometrical figures he represented, he studied, and quite new dimension he developed in set theory. And basically sets are represented here in this way of study, circle and universal set as rectangle. And next, you see here, in this example, this the set universal set, which is represented by this rectangle, and two circles considered here. The inner circle's name is B, and outer circle name is A. Here nothing, just the two sets are shown within universal set, where A is the bigger circle, and A contains, if you see, some elements here like 4, 6, 2, 8, 10. These five elements are there in set A, and inside the set B, two elements, 4 and 6. That means B is the set comprising two elements, 4 and 6. And A is another set which comprises 2, 8, 10, along with the elements of B, 4 and 6. So A consists of, in total, 5 elements, and B consists of 2 elements, 4 and 6. And some elements are written outside A, that is 1 here, 9 here, 7, 5, 3. These elements are lying outside A, but definitely these elements will be lying somewhere in some particular set. That set is not defined here, but outside the considered sets A and B lying means definitely they will be lying in the universal set. So here two sets considered only. So out of these two sets, some elements are lying here, and these elements are uh, um, 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 lying outside these two sets. So definitely they are lying inside the universal set. So definitely it would be always here. So if we consider 3, 4 sets here within the universal set, then also some elements might be there which are not in the considered ABCD sets, 4 sets. Out of these 4 sets, if you consider 4 sets inside the universal set, even then few elements might be there which are not belonging to the four sets, and they may be lying outside the four sets. But outside the sets, considered sets lying means definitely they were lying under universal set. So the biggest set considered. So it is just uh, interpreted how the elements of different types of sets can be considered as included, and that is lying inside the set or lying outside the set, on if it is lying outside, if they are lying in any other set or not. So just diagrammatically the elements are shown here in this figure. There's a basic idea that this is also might be a way to observe what actually sets are. Now operations of sets. Now operations, that is union of sets, intersection of sets, difference of set. In these sets also, in operations also, we will be using this Venn diagram. With the help of Venn diagram, it becomes very easy to understand this. Union of sets, union means the literal meaning of the union. You can understand this union, it's merge, unitedness. So if two sets are there, and if we collect all the elements from both the sets, then we will have a new set, and that new set will be union of the two sets. So this is just a collection of all the elements from the sets. If there are two sets, then all elements from the two sets, if we collect a new set, we will be having, and that is union of the two sets. If there are three sets, then union of three sets. If there are four sets, union of four sets. Just it's a collection. Union is the collection of all elements from the set considered. If there are two sets A and B, then collection of all elements from A and B is the new set, and that is union of two sets. No single element should be left in this collection. So that is why it is union. And symbolically, it is like capital letter U type symbol is this one. So A union B. It is usually read as also A union B. Symbol is this one. So it's example through example, very simple here. An example is here, the example number 12. A is one set which consists of 2, 4, 6, 8. B is another set considered which consists of 6, 8, 10, 12. Now find A union B, and we need to find A union B. A consists of these four elements. B consists of another four elements. Now union. So A union B will be, we have to collect all the elements from A and B. 2, 4, 6, 8, 10, 12. 8 is present in both the sets. So we need not to write 8 twice here. We have to write once only. Similarly, 6 is present in both of the sets A and B, but we need to write 6 once here because it is just a collection of all elements. So since 6 is there in the union, that means 6 is lying in A, and the same 6 is lying in also B. So after all, we have collected all the elements from A as well as B. So this is simply A union B. Similarly, say in the next example 13, A, E, I, O, U, all vowels are there in set A, and A, I, U, three vowels are there in set B. So obviously, if we write A union B, then all the vowels will be are here. So A union B is A, E, I, O, U, and all the elements of B and all the elements of A we have collected. So A, E, I, O, U. And so all the elements of B here actually are there in the set A. So it is no problem. It is not our problem. Our target is to collect all the elements. No single element should be missed in this collection. So it is just we need to collect all the elements of A as well as as well as B. Similarly, this one union. Now, diagrammatically, if we observe, you see here in the figure, U is the universal set, and A is one circle, and B is another circle. This circle, A circle, means the set A, and B circle means the set B. So elements are not given here. It is generally diagrammatical representation. So A circle means all the elements of A, and B circle means all the elements of B are here. So some elements might be lying common in both A and B. So that's why these two circles are intersecting. So a portion in the middle one, a intersected portion is there. Which portion is, if you observe, this portion is lying in A as well as in B. So this is common portion. So this intersected portion is common. So if some elements are there which are lying in A as well as in B, that means common. So common elements are possessing this space. So this is intersection. This is for common elements. So common elements we have to write here so that the elements enter in both the circles A and B. So that's why it is just a general representation. So A union B. A union B means collection of all elements. So all elements, that's why A and B, both the circles are shaded here. Shaded here. Shaded means all the portion, entire portion is represented by A union B. And A union B in set builder form also we can write. Here in the definition it's given here, and just below if you see A union B is equal to, within second bracket, X such that X belongs to A or X belongs to B. This is the representation of sets language, that is set builder form. And this is the diagrammatical representation A union B. And in set builder form, we used to write like this: X such that which X are here, those X which are belong to A or belong to B. That means A union B is the collection of those elements which are lying either A or in B, either A or in B. And in this way, if we define this, no single element will be left from both A and B. No single element will be left because it is defined in this way. X must belongs to A or X must belongs to B. So this is simply collection of all elements from A and B. A or B. The union of representatives, just the file diagram. Okay, some properties of operations of union are here, and this can be proved actually with the help of figures. And A union phi is A union A is equal to A. Universal union A, this universal set. It is a simple observation. Phi there is no element, so union of phi with any set. So set will remain as it is. If two same sets are considered union, so answer will be same A. So A union A, obviously A. With any universal set A, union is considered. So definitely the bigger one is the result. So universal will be that is collection of all elements, union means. So universal itself collection of all elements, and A is lying there. So the very simple properties here. And intersection, another property. First property was union of two sets. Next property is intersection of two sets. Intersection means what? Common. See this figure. U is the universal set, this rectangle. A is this circle and B is this circle. Here shaded portion you observe, this is the portion which is common. Common means this portion is lying in A and in B also. So this is common portion, so which we call intersection. It is intersection. So A intersection B is represented diagrammatically in this way. So this is the representation, diagrammatical representation of A intersection B. So this shaded portion is the actually answer of the question A intersection B. So this shaded portion is the common portion because this is the only portion which is lying in both A as well as B. So diagrammatical representation of this. So if we write using set builder form, intersection of sets here, if you see here, A intersection B is equal to X such that X belongs to A and X belongs to B. You know, if you observe definition, then how the elements are defined. So first, X must belongs to A and it is not or. It is not or, and X belongs to B. That means only those elements are there in the intersection which belongs to A and B. That means in both the sets must be lying. If X belongs to A and X belongs to B also, that X will be there in this collection. So only those elements are there which are lying in both of the sets A and B. That's why we usually say common elements. So simply common elements, collection of common elements is the intersection. Collection of common elements is the intersection. So it is in set builder form, it is defined in this way. A intersection B is equal to X such that X belongs to A and X belongs to B. It is and, an important word, and. And in union, here it is or, because union is collection of all A and B. All the elements of A and all the elements of B must be there in the collection. So that is or. So here it is and in intersection. Okay, simply collection of the common points. So here is a simple elements. So okay. Thank you so much for joining this. I had tried to use this platform, and I didn't work with this platform actually previously. So anyway, thank you so much. Actually, time is likely to be over. It's showing here in this platform. Anyway, thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, sir.